Good day and welcome to 501 Math Leap, where we work smart, not hard. In today's problem, we're given this diagram of three squares. The two smaller squares have the areas of 1 square centimeter and 9 square centimeters respectively. Just with that information, we're to determine the area of the largest square. Pause the video here, see what you can come up with. I'm going to solve it this way. So let's see, first off we're dealing with squares, so we know that the formula for the area of a square is side squared. Or alternatively, we could say in reverse, the side is equal to the square root of the area, where we can call this side of the largest square y. But before we get to finding the value of y and the value of the area of the largest square, let's find the side lengths of those two smaller squares. So for the smallest square, the side will be square root of 1, which is just 1. And for the medium-sized square, the side will be the square root of 9, which is 3. So let's place those on our diagram. Let's see, what else do we know? Well, if the height of that smallest triangle is 1, what will be the base? Well, as we can see, it's right on top of the medium-sized square, which has sides of 3 and 3. So the smallest triangle also has sides of 1 and 1. So if we subtract 1 from that 3, that will leave us with the base being 2. We also know that the height of that medium-sized triangle there is 3. So can we find the base? Well, let's see. Well, we can use similar triangles. As we can see here, that small triangle is exactly the same as that medium-sized triangle, but just a scaled down version. Why do we know that? Well, as we can see, there are 3 equal angles, right? Both of them have a right angle. Both of them are parallel sides, the heights of both of them. And so the two angles at the top are the same, right? So those are similar shapes as we see here. We can take that small blue triangle and shift it down, where we can now call the base of that larger triangle x, and you see that it is just a scaled up version. So how can we find x? Well, according to similar triangles, the height of the small triangle 1 compared to its base 2 is equal to the height of the bigger triangle 3 compared to its base x. So we can cross multiply. 1 times x will be equal to 2 times 3, or in other words, x will be equal to 6. So we have values of 1, 3, 2, and 6, and if we make a construction line right there, we now see that we have a right angle triangle where we know the base and the height of that triangle, and the hypotenuse is y, which is the side length of the biggest square which we're looking for. So according to Pythagoras' theorem, a squared plus b squared is equal to c squared, where in this case we have that the height is 1 plus 3 and the base is 6 plus 2. So that simplifies to give us 4 squared plus 8 squared is equal to y squared. 4 squared is 16, 8 squared is 64. If we add those together, we get 80 is equal to y squared. Now at this point, you might want to square root that to find the value of y, but we don't have to because we're looking for the area of the largest square. And so the area will be y squared. So in other words, we have already found the answer. The area of the largest square is 80 square centimeters. Did you get it right? If so, comment below. And as always, if you found this video useful, please hit that like button, share with others, and subscribe if you're new here.